Hello everyone. CONSTEKNOSforum welcomes all you construction technocrats. We are going to discuss today about the launching of long span steel truss for railway bridge by push launching method. Push launching may also be called pull launching or incremental launching. Let me take to the Mokama railway bridge project where 2660 metric ton steel truss is being launched by push launching method. The northern end of this bridge is located at Simariya Dham on the bank of the holy river Ganga. Simariya Dham has a religious importance for this area where Ardh Kumbh Mela is organized in every 4 years. There are several ancient temples situated in the alignment of this bridge. Therefore, launching of the truss cannot be done by ground support method. On the other hand, being a shore span, cantilever method also cannot be adopted due to non-availability of anchor span. Incremental launching or push launching or pull launching is a construction method commonly used for the construction of steel bridge superstructure, particularly those with long spans. This method involves the progressive construction and launching of bridge segments, allowing for continuous erection until the entire bridge is completed. The incremental launching method is particularly suitable for area where there is limited access to the construction site or where there is a need to minimize disruption to existing infrastructures such as waterway or traffic or a religious place like Simariya Dham at this location. The construction begins with the preparation of foundations. Typically, we can call it as launching pad, which serve as the support for the bridge superstructure. The foundation design must be robust enough to withstand the load imposed during the launching process. It is a RCC wall with 16 mm thick steel plate on top and 3 mm thick stainless steel plate above this 16 mm plate to reduce the friction while pulling the truss. launching nose is assembled at one end of the truss. This structure provides the necessary support and guidance for the incremental launching process. The launching nose will be assembled in front of the truss to be launched. The nose is required to reduce the bending moment of the superstructure during launching process. Temporary supports such as slider beam, launching platform, launching bearing, pulling bracket, pulling beam, trussel or nose erection etc. are placed to provide support, stability and ensure a smooth launching process. The incremental launching process is performed by hydraulic jacks mounted on pulling brackets which are firmly attached to the substructures, which is abutment A2 here. These hydraulic jacks are used to pull the strands which are anchored at the other end of the launching truss with a pulling beam arrangement. As explained earlier, hydraulic jacks shall be used as a pulling device and it should be mounted over the pulling bracket. The total length of bridge superstructure to be launched is 100 meter plus 110 meter, which is equal to 210 meter. Weight of 100 meter span is 1250 metric ton, whereas weight of 110 meter span is 1265 metric ton and weight of launching nose is 145 metric ton. Hence, the total weight to be launched is equal to 1250 metric ton plus 1265 metric ton plus 145 metric ton, which is equal to 2660 metric ton. The horizontal force required to pull or push an object is equal to the frictional force developed between the contact surface of the object and the surface supporting the object. And this friction force depends on the coefficient of friction between the two contact surfaces. Here, 7% friction is assumed for longitudinal motion, since virgin Teflon sliding pads will be used for launching which has very low coefficient of friction. Total force to be exerted by pulling jack at 7% friction for launching is equal to 186.2 metric ton. The girder will be pushed using two jacks. Hence, the force to be applied through one jack is equal to 93.1 metric ton. Assumed efficiency of jack is 70%. Required capacity 133 metric ton. Available multi-strand hydraulic jack capacity is 250 metric ton. This is the same jack used for pre-stressing of PSC girders. So, we are using two jacks of 250 metric ton capacity having 600 mm pulling length in one stroke. With the help of stands that are connected at the pulling beam connected at the end of segment to be pulled. Since the initial position of the truss erected on the launching pad is 15 meter away from the abutment, the total length of pulling including the gap between two span is 225.3 meter. Therefore, to push a length of 225.3 meter, 376 strokes of the hydraulic jack will be required at the rate of 600 mm per stroke. To pull, the total frictional force of 186.2 metric ton, 11 strands of 15.2 mm diameter will be used for each hydraulic jack. Eight launching bearings, 4 on each side, are installed under one truss. It has two purposes: to support the truss and to make sliding of the truss easier by reducing friction. A Teflon sheet is provided at the bottom of the bearing to reduce friction, and an elastomeric pad is placed between the steel bearing and the Teflon sheet for cushioning.